Hey guys, this is Mr. Grice for Miss Carranza and Mr. Grice's Algebra 2 class. Today we're going to be talking about section 1.4 notes, part 1. We will be discussing different sets of numbers. Our learning target for today is to identify, compare, and graph different types of numbers. Okay? Now, for all of the definitions for these words, please look at the key for the Algebra 2 section 1.4 notes. The only ones that I'm going to briefly talk about real quick are rational numbers and irrational numbers. Okay? Now, a rational number is any number that can be written as a fraction of integers. And the key thing right here is it has to be able to be written as a fraction. Okay? Now we're not just talking about any fraction here. We are talking about a oh, sorry. I was looking at the wrong one. So we were talking about a repeating or ending decimal. Okay? So if we have the example 1/3, 1/3 is 0.33333. This is a repeating decimal, but we can write it as a fraction. Okay? Now, even if we had 0.125, okay, that can be written as a fraction. Okay? So as long as it can be written as a fraction, it's a rational number. Okay? Even negative 2.5, okay, that's negative 2 and 1/2. Okay? All of those are rational numbers. Irrational numbers are numbers that cannot be written as a fraction of integers, okay? And this is cannot be written, okay? So here we are talking about non-repeating or non-ending decimals. And some examples that we gave in class was this number right here, pi, okay? Many of you know it's 3.14, but it is 3.1415, blah, 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 and it just keeps on going. There's no pattern to it, okay? Another number would be the square root of 7. It's another number. If you plug it into your calculator, there's going to be no ending to this, okay? Now, and for the other ones, just make sure to look at the notes. To kind of organize everything, all the numbers that we're going to talk about are real numbers, okay? Now, real numbers can be broken down into two groups. They can be broken down into rational or irrational numbers. Now, a rational number could also be considered an integer. Integers could also be considered whole numbers, and whole numbers could also be considered natural numbers. Okay? And to get all those definitions, once again, just click on the answer key so you can write them all down. Now, example number 1 says, given the set of numbers, all in here, list all of the integers, natural numbers, whole numbers, rational numbers, irrational numbers, and real numbers. So let's go through and take a look at some of these. Now, the integers in this group, okay? The integers are -9 and 0. The natural numbers here, well, the one thing we want to look at real quick, look at this guy, square root of 49. Do we know what that is? If you don't know what it is, plug it in your calculator, because it is 7, okay? So a natural number in here is the square root of 49. Whole numbers. Whole numbers in this group are 0 and 49. My rational numbers, -9, 0, 3 over 10, because that's a fraction, square root of 49, and 2.33 repeating, okay? My irrational numbers, we only have one in this group, and that is pi. And the real numbers on this are all the numbers on the list. Okay? Now, key things to remember that integers can also be rational numbers. A whole number could be a rational number. Natural numbers can be rational numbers. Okay? So some of these numbers are going to be on multiple lists. All right, let's look at example 2. It says, given the set of numbers 23, -6, 4 over 9, square root of 5, 2.35821, ... Okay, these dots is our reminder that that number keeps on going. Okay, 7.8 and 5 1/3. This number can be written as 5.33333 repeating. Okay, so let's take a look. Rational numbers. Well, 23, -6, 4 over 9. Square root of 5 is no. 2.35821, ... No, because that can't be written as a fraction. 7.98 and 5 1/3. My irrational numbers, square root of 5 and 2.35821. And now our integers are just going to be numbers without fractions, without decimals. It's 23 and -6. All right, let's go ahead and flip it over. Now it says graph the following numbers on the number line below. So if we're going to graph, we need to make sure everything's labeled on the bottom. So I'm just going to write these down so we know where to put our numbers. Now let's take a look at some of these. We got -4, 7 over 8, 3, -2 and 1/2, 5 and 4/9, and 0.9. So what we need to know is we need to know exactly where all of these numbers go. And 7 over 8 and 5 and 4/9 is not going to be something that we can get right away. Okay? So let's try and find where these numbers are. Now, remember that that bar means to divide, so we are going to do 8 divided by 7. And now 8 doesn't go directly into 7, so we're going to have to add a 0. So how many times does 8 go into 70 without going over? 8 times, because 8 times 8 is 64. We subtract after we borrowed, and we get 6. Now, we got to keep going. So we got the 0. Drop it down. How many times does 8 go into 60? That is 7 times. 8 times 7 is 56. We're still not done. Let's add a 0. Drop it down. How many times does 8 go into 40? And that is 5 times. And we're done with that one. So 7.8 is really 0.875. Oh, negative 2 1/2. We can do that real quick. That's negative 2.5. And 5 9/4. How are we going to do that? First, let's turn this into an improper fraction using the checkmark method. 5 times 9 plus 4 all over 9, and we're going to get 49 divided by 5. So how many times does 9 go into 49? And that is 5 times. Subtract that, you get a 4. Add a decimal, bring it down. Now, how many times does 9 go into 40? That's 4 times, and you get 36. Oh, that's not supposed to be a 0. 0 minus 6 is 4 after we borrow. All right. Bring down another 0. Oh wait, this starts to look familiar. How many times does 9 go into 40? Well, that's 4 times. 36. 4. Okay, and that's going to be 5.44 repeating. Every time we work that out, it's always going to come out with a 4. Okay? Now, all we're going to do is start plugging these numbers now. Starting with negative 4. Negative 4 will go right where the negative 4 is at. I'm going to put a dot and label. All right. Next is 7 over 8, or 0.875. I know it's going to be very close to 1. So there's 7 over 8. There's 3. Negative 2 1/2 in between the negative 2 and the 3. 5 4/9 is 5.444. And the last one, 0.9, which is right afterwards. Okay? Now, what we're going to do is using that number line, we're going to insert our symbols to make a true statement. Okay? And the farther to the left a number is on the number line, it is smaller. So 0.9 and 7/8. Let's actually take a look. So here's 7/8 and 0.9. So since 7/8 is to the left, that means that that number is smaller. And remember that our symbol, the Pac-Man, always wants to eat the bigger number. Okay, let's look at 3 and 5 4/9. 3, 5 4/9. Which one's bigger? Okay, 5 4/9. Is Pac-Man eating the bigger number? He is, so we're good. Okay. Why don't you guys go ahead and pause the video and finish example number 4. Okay, this is what you guys should have gotten. And finally, for the statements below, we got 1.38 and 11 over 8. Which one is bigger? Good, the 1.38. And, oh, I forgot to draw this one, which was negative 3. Negative ones are the ones you have to be very careful. Which one is farther to the left? Okay, that's negative 3.5, so that means my negative 3, or what that one was negative square root of 9. That's our bigger one. Okay? All right, that's it for Algebra 2, Chapter 1.4 Notes, Day 1. Remember to get all the definitions and everything from our notes, the answer key that's already up on the website. Okay? If you guys have any questions, please feel free to come find Miss Carranza and myself. Thank you very much, guys. Have a great day.